Hi guys, welcome back to our ML journey. After seeing how to deploy our ML app in cloud, after train and build the model in Sagemaker, today we are going to see how to use ML pipeline with the tool called ZenML. Know that ZenML helps us to build end-to-end machine learning workflow. It also enables us to integrate various components of ML stack such as orchestrator, data store, and provider. As you can imagine, we will cover ZenML. It is similar to the MLFlow. Let's go into our example. Here I prepare for you. I don't see if do you have my screen too big. Okay, as you can see, I am in Google Colab. Why I'm in Google Colab? Because as you know, Google Colab allows us to run some ML pipeline without worry about memory size, because you know locally you can be limited. Here in the Google Colab you can have some GPU, CPU running for free, okay, and you can manage large volume of data. For use our ZenML, we need to install some tool. We need to install ZenML server, ZenML. We need to also install ZenML and integrate it to scikit-learn. You need to install parsing library and import Python. As you can see, I already installed this tool. I will not run again this instruction. As you can see, I use ngrok token to make publish my MLOps pipeline. Okay, here I remove all existing ZenML folder and then I initialize a new folder. I already run this command. Please don't forget to provide here your ngrok token. Okay, when you create your ngrok account, you will set a token and you copy this token and paste here. Okay, for security reason I didn't show you my ngrok token normally. Okay, let's see what next. Here we need to import our data. Okay, here I will work on a recommendation system and it will be a movie recommendation system. Okay, and this movie recommendation system will base on the rating of the user. I will show you how to produce the movie, how to recommend the movie to one type of user based on his own rating. Okay, I need my rating CSV file and then the movie CSV file. To do that, I use a read CSV function, but I need to, before importing my data, I go here, I click to upload my data. I have data here, movie rating, click open and see here my data is been uploaded in the Google Colab file folder. Okay, that is done, and I can now run the cells. Okay, it was succeed to run. Okay, you can check it by test our function, run it here and see what output. Do you see here? This is our rating tab table. Okay, rating, movie ID, user ID. Okay, it's rock. Well, I remove these cells, and then we execute this command that allow us to retrieve our movie CSV file. It succeeds. It's green light. Here I make some pre-processing and merge the two CSV file, rating data and movie data. Okay, based on the movie ID column, and then I drop some unnecessary column. You can see here, time space jar. I create user item matrix. Okay, and I return it. Let's run these cells. Here I split the data with a test type that contain 20% of our total of data, test data, and remember 80% is the train data. Okay, which is very common in the ML job. Okay, let us run this step. I use cosine trainer to find a similarity. Okay, know that you have many distance to know the similarity. You have similarity of Jakarta, distance, Euclidean distance, cosinus distance, or correlation coefficient also. Okay, here I use cosinus distance to estimate the similarity between two rating or two movie. Okay, it's done. And here it is other distance used here is correlation coefficient. Okay, correlation of coefficient of correlation is done here, and then I am able to make some recommendation. Okay, with this function. Okay, you see here the output of this function will be a data frame, and it take some input like user ID, train data, item similarity, user item matrix, movie data, and it retrieve the top 5 of the movie with the high rate of similarity. Please see here the user ID, because we need it to get our recommendation. Okay, we need to enter this input. I leave you see in the detail this code. It's not difficult. If you have any problem, feel free to ask me. I will run these cells. Okay, it's done. Yeah, I construct my pipeline. Okay, with at pipeline, and it's possible because I put here on the step at step this instruction. Okay, to mention that this is the step I use in the pipeline. Okay, I have some step. This is the recommendation step. This is the coefficient correlation step, cosinus distance steps, the split data steps, the pre-processing of data steps, import data step. Okay, and now I am able to run the pipeline, will run step by step. Okay, let's see it here running. my pipeline is good. You see here, we need to enter a value. This value, as I showed you before, is the user ID. You can see, you can choose for the user number 10, they will go see and rate, and on it our model, our recommendation system will make some recommendation to this user based on his rating. Okay, let's see here the second pipeline with now the coefficient correlation, like the type of our distance of our similarity. And now here we will run our first pipeline, who is used for cosinus distance to compute the similarity. Okay, I will run the cells, and they ask me to give the user ID. I will choose randomly one user ID. I will choose user ID number 40. I will click enter. You see here that our pipeline begin to construct, to run. Okay, initially a new run for pipeline, and you have here user, using user is default. I didn't specify any user. Orchestrator default, artifact store default. We see the import data movie has start and finish. We succeed. Import data rating, start, finish in 7 seconds. As you can see, the step pre-processing has started. It takes a little bit time to run. You know, I have a big data set. I think it's 25 million of line in the rating 5. Okay, it's very big file. Okay, that is why I didn't run it locally on my machine, because they need a lot of resources. If I want to run it locally, I need to reduce the volume of the data set, but 25 million is very large. That is why I'm running here in Google Colab. Okay, as you can see, our step pre-processing has finished. We succeed, and then we split the data. You see here our the number of line in the data set, if it's 5,000, and the test set is 1,000 around. Oh nice, the split data is finished. We succeed, but very long to execute. Normal, because as I said before, we have a large data set. And then here we compute the distance. Our item similarity is finished, and then the get recommendation has started. Oh nice, this is our recommendation movie given by our model. Here you see for the user ID number 14, our algorithm recommend 5 movies. The first one is Glengarry Glen Ross, published in 1992, genre drama. The second one is Full Speed. The third one, Odd Couple 2, is a comedy genre. And the fourth is Junk Mail, but being Jaren. And the fifth, last one, is 5,000 Finger of Dr. T. Okay, we did it. Okay, this is our recommendation system. Let us see it in the ZenML platform. We use this code to launch our ZenML server. Okay, we click here on this link. You see this is our publish IP with our ngrok token, and this is the link, the public link. Okay, I will give here the user is default. Click on login. As you can see, I have one stack, 2 components, one number of pipeline, and one number from front. Let's see our pipeline. This is our pipeline, a success record pipeline. The bullet now I at 12:38. Click on it. You can see our DAG visualizer. You can see here different steps. Import data rating, import data movie. This is the data. Okay, the store here. This is the metadata. Okay. Movie count. Okay, this is the metadata for movie ID, but it's not get a sense, any sense here because it's the ID. Okay. Let's see here, and the next we have pre-processing step complete with the output. You can see the output here. After that we have test set and data and train set split. We have here our cosinus trainer output, recommendation, and we have our output here. Okay, you see this is our pipeline with different steps. As you can see, ZenML is a nice tool to track our model, to build our ML pipeline or our ML workflow, because they allow us to store all these metrics you can see. Here we didn't have a metric like accuracy, if one score, because we work on the recommendation system. Recommendation system, you don't need any accuracy, any indicator of the quality of your system. Okay, but it seemed to be work well. Okay, this is what I want to show you, guys. I hope that you enjoy this tutorial. Please feel free to ask me any question. Okay, as I mentioned, I will release all the material needed in this tutorial in the description of the video. Thank you.